There we go. Good afternoon, everyone. We'll get stuck straight into it today, and this session will be recorded. So we'll make sure that we email out a recording of the session afterwards to review. But we're very pleased to announce the release of version 25 of IDEA StatiCa, which was released on April 24th, so a couple of weeks ago now. There's some great improvements that we'll go through today, both for steel and also the introduction of the concrete module. Our speakers today, myself, Tom Malloy, the segment manager here at BuildingPoint for the Structures Division, and we've got Khaled and Nick from our engineering support team. They're senior technical consultants from the engineering division. Nick will begin today's session running through what's new in version 25 for steel, and he'll then hand over to Khaled, who will run through what's new in version 25 for concrete, including the introduction to the AS 3600 module for concrete in Australia and New Zealand. So I'll hand over to Nick. You can get started and we'll go from there. And at the end, we'll also take questions. So thank you.
Well, thank you very much, Tom. And just checking, first of all, that I'm sharing correctly. Let's just check this. Okay, got to go to my PowerPoint and go to present mode. So thank you, Tom. Let me know if anything's not coming through properly. All right, so let's start at the beginning. IDEA StatiCa Steel. As Tom mentioned, version 25, there's lots of great new advances in the software in relation to editing, parametric connections, also in exporting and grouping within CheckBot if you brought connection details in from space gas or similar frame analysis and design application. So let's just get straight into it. So first of all, when you open IDEA StatiCa version 25 steel, you notice quite a bit of difference in the start page or the start wizard, it might be called. And but it's, of course, very intuitive and a typical type of connection, a standard type connection could be opened in 3 easy steps, for example. So on the left side, we select the required geometry. It could be a beam to a column connection. The column could be continuous or otherwise, or beams on both sides, or truss node connections and so forth. And with each of these, there's a drop down typically, so you can select a slight variation within that. And then in the next column to the right, we'll start getting some specific connection types that are part of that category or that geometry subgroup. And we also have some nice filters here. So the bearing member can be of any shape. Similarly, the connected member or members, or you could filter these for eye sections, rectangular or square hollow sections, circular sections, channels, etc. And also we can tick or untick various categories. So predefined, these are the connections that are shipped with the software, but we might have also published some connections to the company design set. So somebody else in our user pool, or perhaps myself, has done some work in setting up a connection, and we'll see that could be of a standard nature or a parametric nature, and that can be published. And that will, if it's been published to the company design set, then that connection will be available to everybody in the user pool in that company. And we can filter these things on and off for built-in or company published templates, or personal for myself. We can also do a text search up here. So lots of good options for selecting the template or the connection arrangement that you want. And so it's simply a matter of selecting that template. We can actually rotate and zoom into the connection view on the top right there, make sure we have the correct design code, and create selected template. Now, something I'll go into quite a bit shortly is the parametric nature. So this is much more exposed now. We don't have to use the parametric nature of connections. We can use things, the connections in the same way as we did previously. But the parametric connections offer a lot of good time savings. So where you see a capital P next to the connection, that is a parametric connection, which offers then a simplified method for data entry. And there's more than 200 parametric connections shipped with the software. All right, and let's also move to some other groups. So if we scroll down to the bottom on the left-hand group options, we can select all geometries, which doesn't restrict any geometry, of course, or timber groups. They were there before, but we've got an expanded set here and some parametrics and so on. And so that's where we find timber member options with certain types of steel connections, and also a seismic group. And if we currentally select that option for Australia, we don't get any connections, but we can select, for example, a Eurocode or American code, AISC, as I have done in this occasion, and then we are presented with quite a few options. So if we in fact want to use one of these connections, then we can open it, say, in the American code, then publish it in the normal way to our company or personal design group, for example, and then come and start another connection to the Australian code and select that connection that we've just published. So these connections are available to us as well. So there's some really nice options there. And by the way, these have been pre-designed, so to speak, and they have some validation checks to ensure that they comply with the limits for seismic design in United States, for example. And let's have a look at a parametric template in action. The idea of these is that this will greatly simplify common and repetitive actions, common styles of connections and so forth. As I say, there's many parametric connections shipped with the software, and we'll see this right here. So I might be working with a connection. It's not working at this stage, but and I can see that there's some excessive plastic strain and so on. What we do from the design tab is select the operations title and then use the simplified entry options up here. And the expressions behind the scenes will drive the other operations in that connection. I've reanalyzed and with buckling, and I can review the connection, and things work on this occasion after increasing the size of a range of items here. So that's the idea of the parametric connection. We select the operations title and use the simplified entry method. Now, it's possible to develop these connections or maybe make some adjustments to them, and even if they're parametric, publish them, as I said before, to the company design set. And if you tick on the parametric option here, so if that connection has been defined as a parametric connection, of course, it's available to be saved in that fashion and shared to others in your user pool. So, you know, this we can see that this is I guess a new beginning of possibilities to share smarter, quicker type connections for the typical users in the company. So particularly for favourite types of connections in your firm, here we have a nice way to make those connections more responsive and quicker to use, and of course share these things around. All right. Now, if we don't want to utilize the parametric operations, we can right-click on the operations title here, or select that title, and at the top right there'll be an explode option. So it's a matter of exploding the parametric template, which then removes the expressions behind the scenes that have been set up to define the automation, and the various operations remain, but they are just of a standard type. So if we don't have the developer tab selected, we'll see here that the various operations are grayed out. So we might be a user of the template and we're going to stay within the various limitations and so forth that have been set up. We select the operations title and use the simplified entry method. But if we want to make some other adjustments, we can explode this template, and then we're just back to a normal type of connection that we perhaps are used to. And we can combine the parametric templates and normal operations. So just to illustrate, I started with a parametric connection here. We see the P I started with this and I got most of these connections together. And so the simplified entry, again, we select the operations title, and we can enter plate thicknesses and various offsets and so forth to drive the truss part of this connection. But I also added another member using add member, and then add operation to add a shifted end plate here, SEP. So that's a normal operation here. So these things can be combined. We can still use the shortcut or simplified method for the parametric aspects, and we have other operations as well. And of course, we can save and reuse these details as usual. Something else that's, I think, very nice is the, beg your pardon, go up, the ability to save custom sections to our materials and products reference library. So here I have gone to the materials tab, defined a custom fabricated box section, and then I wanted to save that. So I clicked save to MPRL. And if we're doing it for the first time, we might have to just select plus to create a new category in the MPRL, and then save this connection. And after that, we might start a new connection. I've got a column and a couple of beams, no operations just yet. And I wanted to add, not edit this I section and get a new I shape, but I selected the plus symbol next to the edit option to create a new type of connection for this connection model, or a new type of section, I beg your pardon, for this connection model. And so I selected welded composed and then the box sections, and I can then edit a section in the normal way, or call up the custom options here and go to the custom category and select the section that I've previously saved and OK. And then we see that that cross section will be the connection, or the cross section that I've saved previously in my products and reference library. Another really nice advantage, previously when we selected slotted holes in a connection, it was up to the software to a certain extent to determine whether those slotted holes were on the cleat or on the beam web, or which plate in the connection. And of course we can have multiple plates, not just 2, we could have up to 10 actually in the software. So now we can define slotted holes on any of the plates, and in fact on multiple plates. So dealing with potentially more complicated situations, there's one restriction: we need to have at least one plate with normal circular bolt holes, so for stability and so forth. So a good step forward with slotted holes. And when we're reviewing results of a connection, there's been a way for a long time to restrict the results to a particular load case or load combination. But it was a little bit hidden in a sense in the check menu. It wasn't quite as obvious, but now in version 25, it is a lot more obvious. If we select the load effects title or the group title below that, we will get all of the results considered in the normal way. But if we select one of the load cases here that has been run, then all of the results, the summary, and all of the results depicted and the 3D view will relate to that load case only. So it makes it easier to review specific load cases that have been run. So I think that's another nice step forward. So there's a few other improvements with reports and other details like this, but I think linking from packages such as eTabs, Robot, and so on, and in a very popular program in Australia is of course SpaceGas. These links are very popular, and the development of the link and operations to improve the speed of working through the different connections has continued to improve. So I'd just like to illustrate a major step forward with recent versions in terms of grouping. That we saw a little bit of this last year, but we've got some more automation here. So I'll just set this little 3.5-minute video going. Here's a sample file of a portal frame within SpaceGas. And of course, we should analyze it, and I would normally do a nonlinear analysis to, for anything with lateral loading and so on. Now, we want to link to IDEA StatiCa, say from that menu, but there is some checkbot information already in place. I've deleted that first, and we start from fresh. We select the correct code, Australia in this case, and then at the beginning we nominate that we want to select some connections. So we switch back to SpaceGas, select, say, the whole frame if it's not too huge, and press enter. And then we see a replica, in a sense, of the frame in checkbot. So a couple of things we want to do here: merge some members and also tweak the loading. So here I'm going to merge a few members down the center. I took a bit of that out of the video. And in the central column, we might want to delete a few cases that, these are the ones that will go to the connection. And if we delete something we don't want, we drop and drag into the column from the left. And we could evaluate critical load cases only. It's an option there by selecting the title. So let's have a look. I select that connection. I want to now open up that connection and apply plates and other details. But we now see that there's some automatic grouping and an underlined connection in that group. So the three connections essentially in the center of the column are an automatic group. And if we select the group title, we'll see that this is the reference connection, node 32, it's underlined. And we have an option to evaluate critical effects considering the entire group as well. So now I've gone back to select the reference connection, I've opened it up, and I could apply end plates and other details, but I'm using the propose option here. We can tweak the final details of bolts and other things, and then the connection template has been applied. It could be parametric or a normal one that I've saved previously. Now, when we come back out, I didn't analyze it there. I'd simply saved the connection, and the various operations are populated through the entire group. And what we can do is right-click on the group title and calculate all, or calculate each one individually. It's up to us. And we see behind the scenes that the connection details have been populated across the whole group. And in fact, while that's happening, we can continue working. And perhaps we see the green coloration now that shows that they all passed, but we could start or we could continue working on some other details. So for example, I'll select some baseplate connections here, and node 2 at the top right is the reference connection for this. And we see here that some load effects have been removed because they are considered non-critical from the algorithm that's used. So where we have a large number of connections like this, that algorithm might be quite useful to save some analysis time. So for the reference connection, I'm simply adding a base plate to it. I could adjust the details, of course, but I'll simply exit, and the software reminds us we might want to save. And now the connection details have been populated throughout, and I can calculate all in the normal way. So we could continue on. We could merge if we make some changes back in SpaceGas, and we could synchronize that region of the checkbot structure or the entire structural model. So we have a range of options here. So that's it from me. It's over to Khaled shortly, but I think we have some really nice advances with IDEA StatiCa Steel in version 25. And of course, if you have any questions about this, please ask in the question time of this webinar, or get in touch with us at BuildingPoint. Thank you very much. And over to you, Khaled.
Thank you, Nick, for a great presentation. So let me share my screen. So could you please confirm that you can see my screen?
Yeah, we can see it.
Okay, thank you. So let's start with introduction of IDEA StatiCa Detail. So before going to talk about what's new in IDEA StatiCa Concrete, which is Detail, so I want to actually now give you a brief introduction about the Detail. So I believe that IDEA StatiCa Detail, unlike IDEA StatiCa Connection Application, is not that popular. So that's why I'm feeling that it's necessary, to give some information to our participant today. IDEA StatiCa Concrete comes with Detail 2D and 3D. Later, I will go through a little bit more through the Detail 2D and 3D. But for now, just to let you know that what kind of things you can do with IDEA StatiCa Detail application. So I would say that you can actually just go through the different type of design for different type of sections, like RC design, or let's say PT or post-tensioning design, or PC or precast type design, and also composite section design as well. So once you are taking advantage of full advanced analysis, like consideration of geometrical and material nonlinearities, and the real material model of the let's say the concrete material. So the idea behind the IDEA StatiCa Detail 2D, first let's give you some introduction about the Detail 2D, is about designing of the discontinuity region or disturbed region. So as we know, for Bernoulli region, or let's say normal prismatic regions, we don't have any problem. Even our frame analysis application like ETABS, Space Gas, so they can simply design this kind of regions, like as you can see in this slide, like B regions. We don't have any problem. But once it's come to the D region or disturbed region, like the joints, the concrete joints, column and beam joints, or maybe you have the member with opening, or at the corbel location, or even at the pile cap location or foundation location. So what let's say the conventional method that usually we use is about using strut and tie method, which is really oversimplified method, and that's why. So usually, we come with the conservative result. And not only that, so we cannot also go through the SLS or serviceability limit checks as well. So it gives us just the ability to check the result, according to ULS check. So another application that we can go through is about use the advanced analysis software like Abacus or ANSYS or Nastran. But again, so they are time consuming, they are not code compliant, and also using this advanced software required user knowledge in advanced modeling method. That's why so the new solution, and we call it actually now cutting edge solution for this or let's say designing the concrete member or discontinued regions, taking advantage of CSFM or compatible stress field method, and which is a combination of strut and tie method, which is a conventional method, and also it combined with the scientifically oriented programs, as we said, like Abacus and ANSYS. So we combine this kind of tools, and then so we came with CSFM solution, where you can have the both let's say checks, which is after running the analysis, so you can get the code-based checks as well as finite element result and visualization. I prepared some typical use cases just to give you some feeling about the software, how the software works, and what kind of problem you can solve with IDEA StatiCa Detail 2D. As you can see here, some examples for walls and panels. So for coupling beams or panel with non-aligned opening or wall on piles. So this kind of things, simply you can set up in IDEA StatiCa Detail 2D, and you can put the reinforcement. You can do the topology optimization for, let's say, optimizing the geometry of the concrete section, and also you can optimize the reinforcement. And another typical use cases is about the beam of all topologies. It could be beam deams or dab beams or frame corners, and pre-stressing corbels, as we said, and even tapered beam with opening. And in terms of bridge application, so you can go for pier caps, let's say pile caps, diaphragm, bridge deviator, piers. Again, the idea is that, as long as you are dealing with discontinuity region, so the IDEA StatiCa 2D detail application is a solution, and doesn't matter. So you are a bridge engineer, or let's say, the structural engineer, or let's say, designing the buildings or other type of let's say structures. So you can use the IDEA StatiCa 2D for designing the stair regions. But also we have the detailed 3D as well. So the idea about behind the detailed 3D application is to give you a full flexibility and capability of anchoring checks. So most probably you know that in IDEA StatiCa steel connection, or let's say connection application, so we cannot check all the anchor checks. Okay, so that's why we introduced the IDEA StatiCa Detail 3D to get the information from connection application, and then so send the information to Detail 3D and finish up your anchor design, considering full checks. Okay, including the splitting check and other checks that cannot be done in IDEA StatiCa connection application. Here, this is actually an example of complete anchor design check. By the way, once we are thinking about the detailed 3D, is not only about the, let's say, base plate dealing, or checking the anchors of the base plate. It could be extended to different areas as well. For example, here you have a vertical concrete block of the wall, and then so assume that you have the existing wall and you want to connect the new beams to this existing wall. So that's why, again, you can use the IDEA StatiCa connection just to come up, with the modeling, and then so put the anchor there. And once you run the analysis, if you are getting, the errors or warnings for the anchor, so you can send the information to IDEA StatiCa Detail 3D and finish up your work. And definitely for coming up with this solution, doesn't matter for 2D or 3D. So plenty of experimental tests and also some other comparison have been made by IDEA StatiCa team to make sure about the accuracy of the IDEA StatiCa Detail 2D and 3D results. So that's why, as you can see here, for example, this is a, let's say, the depth end example that already, they did an experimental test, and they compared the experimental test with the CSFM method, and also with another proven finite element solution, which is Athena. And as you can see, so they are well agreed in terms of results. So now let's go to what's new in Detail 2D and 3D. So the big news is IDEA StatiCa concrete Detail 2D comes now with AS 3600, which was actually a long waiting for us, and it was about a few months that we were telling you that IDEA StatiCa is going to be let's say supported by AS 3600, and now we have it for Detail 2D. And for Detail 3D, so already, they put the flag there, but the good news is that, it's coming soon. Most probably in the next release, we have the Australian standard for concrete in Detail 3D as well. But the thing is that we have it for Detail 2D, and with confidence, you can go for checking the discontinuity region using Detail 2D. So now let me go through some other slides. So the key features with AS 3600 in Detail 2D is the material database. Already, the building database was implemented in IDEA StatiCa Detail 2D regarding the concrete reinforcement and the steel materials. And also we standardize the nomenclatures like variable names and labels and so on and so forth, just ensuring clarity in design and verification. And also refined calculation just adjusted for the material model stress strain diagram for serviceability and strengths, or ULS and SLS check. And another aspect of checking the discontinuity region is about the checking bond stress, and that's why some important factors like B factors also adjusted to be compliant with IAS 3600. And also in 2D detail, so we have more templates, including the coupling beams. Okay, so this is nice. Previously, we had a limited number of templates, but right now for 2D, including the Australian code, so we have plenty of templates that you can just select the templates and start your modeling. And definitely you can expedite your modeling, and it doesn't mean that you are restricting to selected templates. So you can edit the template, modify the template, and develop the template for yourself. And let's go to Detail 3D. So in Detail 3D, we have some cool improvement as well. So the first one, I want to start with casting plates feature, which is actually, previously only we had the anchoring, with the straight shape, but right now we have the straight shape, L shape, and U shape as well. And the typical application of this feature that right now we have in 3D detail is for facade support system, steel frame connections, elevator guide rail support, mechanical equipment anchorage, bridge bearing and support, and precast concrete panel connection. So just some examples of the typical uses of casting plate anchors. And also we have some other operations in Detail 3D, which previously actually, it was a little bit difficult for us, to come up with this kind of complex geometry, if we wanted to use the basic operations. Right now, we have some advanced operation like negative volume, cutting plate, and cut, and also we can go for merging of anchor blocks using cut operation as well. And so one of the things that just based on our experience and receiving the cases is the merging of the multiple base plates. So right now you can do it actually in Detail 3D. So as you can see here, so I will show you this one in this video. So here, as you can see, so I can use the negative volume, which is actually a new introduced operation to come up, for example, with the pedestal type base plate. Okay, so here I can simply, just place the negative volume around the base plate, and then so I can cut them, and then I can come with the pedestal geometry as well. And then so I can run the analysis and check the results. For example, the stress flow of the anchors and also other options. Another operation that was cutting plane. Again, this helps us to come up with the complete geometry. So you can cut the base plate in any direction that you want. You can place the cutting plane at any direction or rotation. And finally, you can come up with the, let's say, geometry that desire. Okay, and another operation is, again, negative volume, but you can actually now use this operation for introducing new use case. Okay, just assume that you have the base plate. Either it can be modeled from scratch in IDEA StatiCa 3D Detail, or it could be imported from connection application. So you can use the negative volume to come up with the desired geometry as you want. Okay, so here you have all the, let's say, the position in X, Y, Z direction, and also you have the rotation about the X and Y axis. And finally, you can come up with the geometry. And also, as we said, we have the merge option for multiple concrete blocks. So, and using this option, so you can just merge the overlaying and touching blocks like this, or in some cases, maybe you have a uniform concrete block and you want to cut them, so you can use the cut operation and just like here, so you can just separate the let's say concrete block as well. So this is the thing that we have it in the IDEA StatiCa 25. And I think that's all from my side. And thank you for your attention. And please let us know if you have any question. I will pass the floor to my colleague, Tom.
Brilliant. Thanks, Khaled, and thanks, Nick. Lots of exciting developments there for both steel and the introduction of the concrete module. We're very excited about. Just for those on the call, we will be having a concrete road show next week. 3 events. We've got a Tuesday in Brisbane, the 13th of May. The 14th of May will be in Sydney, and then on the 15th of May we will be in Melbourne as well. So please feel free to register for that. If you look on the BuildingPoint LinkedIn page, you'll find the link for that, and you can register. It's a free event, and you can come along for a free lunch and learn much more about concrete. We'll have some guests from IDEA StatiCa APAC in Singapore as well. Now, just having a look at a couple of questions. I think most of it has been answered. There was a first question was from Jono, asking about intention to add New Zealand codes and seismic connections. So we do intend to add the New Zealand design codes in the future. We don't have a timeline, unfortunately, on that yet, but it's definitely on our radar, where New Zealand's quite an important market for us. And we have a lot of customers existing over there already using the Aussie code. And then from Bradley, is the concrete module accessible with the standard license? The most common license in Australia and New Zealand is the steel module only, that most customers have. If you do have a complete license, that will have access to the concrete module, and you can also purchase the concrete module individually. So there's a few different options there. Are there any more questions before we wrap it up? Doesn't look like it. So well, thank you very much, everybody, for your time today. And we'll send out a recording of this webinar, and feel free to reach out to us at BuildingPoint Australia and New Zealand if you have any questions. Thanks, everyone.
Thank you.